The last two examples for the quadratic formula either come out to be no real solution or one real solution. So let's look at 3x squared plus 2x plus 5 equals 0. This one's already set to 0, so everything's in the right spot. A is 3, B is 2, C is 5. Go ahead and plug everything in. Negative b would be negative 2, plus or minus the square root of b squared, so 2 squared minus 4 times a, which is 3, times c, which is 5. And then all of that divided by 2 times a, which is 3. So calculate the discriminant. So you're going to calculate 2 squared minus 4 times 3 times 5. When you do that, you should get negative 56. All right, so just to simplify, so we already know what's going to happen here, but let me just write it out. Negative 2 plus or minus the square root of negative 56 divided by 6. So the reason this is going to be no real solution is because we can't take the square roots of negative numbers. So graphically, what's happening here is this is a parabola that on the graph is not crossing the x-axis anywhere. The solutions would be imaginary. Okay, and then for the last one, we have 4x squared plus 28x plus 49 equals 0. Again, everything's in the right spot. A is 4, B is 28, and C is 49. So plugging everything in, we would have negative 28 plus or minus the square root of 28 squared minus 4 times A, which is 4, times C, which is 49, all divided by 2 times A, which is 4. All right, you want to calculate the discriminant. You got some bigger numbers this time. Definitely want to use a calculator. So 28 squared minus 4 times 49. When you type all that in, you should get 0. So what happens is you get 28 plus or minus the square root of 0 over 8. Well, the square root of 0 is just 0. So we're really not adding or subtracting anything from this 28. So it's like this part of the problem kind of goes away. So essentially we just have negative 28 over 8, which reduces to, if you divide by 4, negative 7 halves. So this is a parabola that if we were to graph it is bouncing off of the x-axis at negative 7 halves or negative 3.5. So it's only one real solution, but we say it has a multiplicity of 2. It counts as 2 solutions, even though it's only hitting the x-axis once. And that always happens when your discriminant is 0.